The main thing that I want you to worry about is rule number 3. It says differentiate implicitly with respect to time. So here's what you're going to write out. So far, we've said dy over dx, right? For every word problem, you're going to say d of whatever variable, oh, I said v, of any variable. That could be a, that could be v, it could be c or whatever, over dt. It is d of whatever letter over dt. Okay, just keep that in mind. Okay, moving on. I want you to write something on the very top. We have this acronym called FWGE, FWGE. It sounds pretty cute to say. And these are very crucial when applying related rate word problems on these. So the first word, F, means look for the word find. Look for the word what? Or look for the word how. And these are similar words, determine. Any of these type of words you're looking for. So when I say find, it could be what, it could be how, it could be determine. The next one. The W stands for when. I'm always going to tell you when blah. That's going to be given to you no matter what. Okay? And then the next one is going to say given. And when we say given, they can give it to you in the phrase of the rate of. So the given rate will always be given to you. And E has to be some equation. Without an equation, we cannot find the implicit differentiation equation. So we have all that down. Okay, let's apply this on number 1. All right, Evan, let's read the scenario on number 1, please.
Air is being pumped into a spherical balloon at a rate of 4 or 5 feet cubed per minute. Determine how the radius is treated when the radius is 18 inches.
So let's all write FWGE. Unless we have all of this filled out, we cannot apply this. So here we go. It says to find, so let's see. It says find or when. So it's to determine how the radius is changing. So the radius is changing here. That's going to be our find piece. So I'm going to say the radius will be what variable? Just by knowledge, common knowledge. So we're going to say dr over dt. If it says the volume is changing, you say dv over dt. Is everyone good with the F part? Okay. Let's look for the word when. When the radius is 18. So next to W, we're going to say R is equal to what? 18 inches. But because I'm thinking ahead, I am going to convert this into feet, 1.5 feet. And we'll talk about why I knew in a little bit. And then they gave us a given rate. Did they give us a given rate right here? The rate of 4 pi feet cubed per minute. And that was our sphere. Now, when I give you a sphere, isn't that the volume in the inside? Okay? So that's going to be dv over dt. It was 4 pi feet cubed over a minute. And let's talk about the cube real quick. Because I'm giving you the volume, does it make sense that I have cube? If I give you the area, what am I going to say? Squared, okay? They're not random dimensions, okay? And our last one, the area. Because we're looking at volume, maybe we need the area of the volume that's given to you right here. So do you have to memorize that volume formula? I'm going to give it to you. Simple ones I'm not going to give, okay? And we'll talk about that as we go over this. So here we go. We have the equation is volume is 4/3 pi r cubed. Although a lot of you guys in my geometry former class, you should have memorized it, right? You're like, no. All right, here we go. Let's start with the formula. I want you to write the formula off to the side. 1v, you don't have to write the 1. 4 pi, not 4 pi, 4/3 pi r cubed. We are going to derive this. So this is deriving the volume with respect to t. All right. Aaron, what's the derivative of 1b? Just 1. But we need dv over dt. That follows you around all the time on related rate. D that letter over dt. The next one. When I derive the next one, would you agree this is a number right here? If I take that number and multiply by 3, wouldn't the 3 cancel? Give me a nod if you're okay with it. 3's cancel. So we have 4 pi, and then r squared, and again, it's dr over dt. dt. Okay, that part was calculus. The remaining is algebra. So I'm going to repeat myself one more time. All eyes on the board. Okay? We derive the volume. I need dv over dt. I derive the radius. I need dr over dt. Are we good with that? Okay? So then moving on, let's plug in what I know so far. So we know dv over dt is given to us. Did we write out dv over dt as something pi? Look to your right. Did we find that? Yep. So I'm not going to go back and forth. I'm assuming you have it on your paper already. So all this was replaced with 4 what? 4 pi. This 4 pi is already there. Leave it alone. What was the radius? 1.5. So let's talk about that piece. Why do you think I converted 18 inches to 1.5?
Was 4 pi.
Because this is given in feet, and not just that part. The given rate is given to us in feet. Do we all see that? It's got to match. Okay, moving on. Do we know dr over dt, or is that what we're looking for? That is what we're looking for. Leave that alone. So here's what I want you to do on your Desmos calculator right now. You're going to type in 4 pi divided by this whole chunk component. So you're taking dr over dt. They definitely cancel, that's right. Put in however you want. Desmos is pretty smart. And I want you to convert that to a fraction, and let's see if that's considered ugly or pretty. There should be a button that gives you a circle with a fraction, a number over a fraction. It's so nice, right? All right, did y'all get a clean fraction called 4 over what? 4 over 9. And it's the radius. Is the radius represented by feet, feet squared, or feet cubed? Just feet. Just feet. So a question like this, you'll use a calculator on the test. If a question like a whole number happens or clean fraction, you're not going to use a calculator. Is everyone good with that? All right. So let's go on to number 2. Okay, Hadley, let's read number 2, please.
The side of a square is increasing at a constant rate of 0.4 centimeters per second. When the side is 5 centimeters in length, what is the rate of change of the area of the square in centimeters squared per second?
And again, that's not random. Area is represented by square. Do we all see that? Okay, so moving on. Let's all write our acronym. We got our FWIGI. It should be pretty cute to say in here. It says to find what? The rate of change of the who? Area of the square. So area is represented by what letter? D. A over dt. These are obvious variables. And then it says, when the side is how many? 5. So we have side is 5 centimeters. Are we good with where we're finding that? What was a given rate? 0.4. So given rate is the changing of the side, correct? So it's d what over dt? ds over dt. And that was our 0.4 centimeters per second. Again, look at our units. My side measure is represented by centimeters, correct? Okay? I'm going to go ahead and alter this. I want you to write out 0.4 can be represented as 4 over what? 4 over 10. And that's because I'm thinking ahead. For the equation, we're running the changing of the area. So area of a square is side times side. Would you agree on that? And that's represented by side squared. So if you're okay with where all these 4 items came from, give me a thumbs up. It's not a secret. Okay? So then let's start with our equation right over here. We have 1a. You don't have to have the 1. To me, it kind of is helpful. So let's write out derivative of the given function with respect to, not x this time, but what? T. Always with respect to time. All right. Someone give me the derivative of 1a. 1. And we write d what? A over dt. Okay, someone give me derivative of s squared. 2s, and then we say d what? ds over dt. Now let's see what components are given to us. We are looking for this, and we have everything else, correct? So let's write out. We have dA over dt is what we are looking for. 2 times, what was our side measure, everybody? 5. And then we rewrote ds over dt as what? 4 over 10. Here's why we did. What is 2 times 5? 10. If I take 10 times 4 over 10, wouldn't the 10s cancel each other out? So our clean answer would be dA over dt is equal to 4. And because it's the area, I'm going to say centimeters what? Squared per second. So if you're good on why I made 0.4 into 4 over 10, give me a thumbs up. So for questions like this, do you need a calculator? Absolutely not. Okay? All right, let's go on to our third one. Okay, on my third one, Mackie, let's read.
The circumference of the circle is increasing at the rate of 2 pi over 5 inches per minute. When the circumference is 10 pi inches, how fast is the area of the circle increasing in square inches per minute?
Okay, I see a lot of you guys with a highlighter or with a pencil. Go ahead and highlight or circle the pieces that are crucial for our Fuigi. And let's see if we agree on what you have circled or highlighted. So it says to find the changing of what? Area, volume, or side? Area. So we have dA over dt. Is everyone good with that piece? Okay. The when. They gave us when the circumference is how many? Good. 10 pi inches. So far, so good? And they say the rate of the who? And that part was the rate of the circumference, dc over dt, is 2 pi over 5, and we have inches per minute. And again, circumference is answered as blank inches. So that means we have 2 equations. So let's see how we know we have 2 equations. Do you see we're looking at changing of the area? Do you also see I gave you a circumference? So why not use both the equations, right? So I'm going to write both of them out just because. We might not end up deriving both of them, but we still want to have our options. Circumference formula. This I'm expecting everyone to know. 2 what? Pi r. And area, I'm expecting you to know. Pi r what? Squared. Here's how you remember. In case you're like, I'm really bad at memorizing. We always have a pi, we always have a radius, and we always have some form of 2. Can we remember that? Some form of 2. I'm saying that because some people like to say the area is 2 pi r squared. That's 2 forms of 2's. Okay? So I'm going to get rid of that real quick. So the first thing we're going to do is ask ourselves, which one do I need to derive first? What do you guys think? Should I start by deriving the circumference or the area? Circumference, why not? If you disagree and you want to derive the area, we're going to get to the same thing. So here we go. Let's say circumference. We said circumference, right? Yeah. 2 pi r. And let's go ahead and derive this. So we have derivative of the function with respect to t. And let's put the 1 in front. What is the derivative of 1c? 1. And we have to put dc over what? dt. And then you know 2 pi is a constant. So derivative of 2 pi r is simply 2 pi times what? d r over dt. So let's see what I know so far. So from the given information, wasn't dc over dt given to us? Okay. So we know that was what? Q pi over 5. And then leave the right side alone. What is on the left and the right that is identical right now? Cross it off. Then we have understood 1 right here. So dr over dt is equal to 1 over 5. Let's see if that's going to be helpful with the next equation. So I'm going to draw a little bar to say, hey, here's my second one. So we have 1a is equal to pi r squared. Okay, let's see. to read this as derivative of the given function with respect to t. What's the derivative of 1a? 1. What do I need after that? dA over dt. Now, when I bring the 2 to the front, I get 2 what? 2 pi r, and that was d what? R over dt. So now let's see if I have everything I need. Do we know the radius, everybody? Let's go back here. If they gave us my circumference is 10, and I plug that right in here, can I now find the radius? So who's my radius then? Very good. So if you're like, hey, I'm missing a variable, maybe you have to plug something in. If that makes sense, give me a thumbs up. We're good with where we found the 5. So here we go. We have dA over dt. 2 pi. Okay, Emmy, what was the value of r that we just found? 5. And then Evie, what was a given dr over dt, or the one we just found previously? 1/5. Now, would a question like this be calculator worthy? Absolutely not. What happens to these two 5s? They're gone. So I know our dA over dt is equal to 2 pi, because it's the area. Am I just going to say inches? Inches square per minute. Are we good with it? So sometimes you may have two equations. Sometimes you may have to derive both of them. That all depends on what is not given to us. Good? Okay, last one. Okay, Polly, let's read the last one, please. Number 4. We're not going to do 5.
The radius of a spherical balloon is increasing at a constant rate of 5 millimeters per second. What is the rate of increase of the surface area of the balloon at the instant when the volume is 36 pi cubic millimeters?
Okay, go ahead and circle the 4 things that are already given to you before we fill out the Fuigi. So they're asking us to find what? D, the area, the radius, or the volume? Area. So how do we represent that? dA over dt. And they should have given when the volume is something. What was the volume given? 36 pi millimeters cubed. Is that unit just randomly cubed? No, it's a volume. They also gave us a given rate. Given rate of the what?
5 millimeters per second.
Was that the radius, the circumference? There you go, dr over dt. So 5 millimeters per second. And again, radius is denoted by millimeters, not squared, not cubed. Okay? For the equation, we have 2 equations for this one. Not only do I need the volume, maybe we also need the area. So let's write out the volume. Volume was already given to us on the front page. Someone read that for me. Volume is 4/3 pi r cubed. And then the area formula for surface area is going to be 4 pi r squared.
That will be given on a test.
If it's the surface area, yes, I'm going to give it to you. Circumference, I expect you to know. The area of a circle, pi r squared, I expect you to know. Side times side, I expect you to know. Okay? All right, so from here, let's see which one we need to derive for sure. So I'm asking you for dA over dt, correct? So I know I have to derive the surface area part. But how would this 36 help us on the volume equation? Find the radius. Let's do that. We have 36 pi, 4/3 pi, r cubed. What is on the left and the right at the same time? Pi. And then when I multiply by the reciprocal, we get 36 over 1 times 3 over 4. And then we have r cubed. Okay, let's see the easiest way to multiply this. Y'all ready? By multiply, I could also divide. Evan, what is 36 divided by 4? 9. And then Hudson, what is 9 times 3? 20 some odd number. 27. And then we know cube root of 27 is a clean whole number of what? 3. So now let's derive the area formula. So I'm going to move on over. If you're still writing, catch up. Okay, here we go. I need all of you to write 1a is equal to 4 pi r cubed. Oh, that's not cubed. No, squared. It is squared. Silly. So we have derivative of this with respect to t. Okay, what is the derivative of 1a, everybody? 1. What do I need after? dA over dt. Keep in mind 4 pi is a constant. What is 4 pi times 2? 8 pi r. And then we need what? d r over dt. Let's see if all the information is given to us. I'm looking for dA over dt. I have my pi r. Caitlin, what was the radius that we found? 3. And then Julie, what was a given rate? 5. So is this one calculator worthy or no? Absolutely not. So here's the easiest way to multiply. What is 8 times 5, everybody? 40 times 3? 120. So we have 120 pi. What am I going to put after the millimeters on the power? Ooh, area. Squared per second. Are we good on that? I'm going to give you a given fact that you don't have to write on the next piece. So, if you can memorize the volume, do you know you can automatically get to the area? And if you're like, I have no idea what you're talking about, watch this. My volume formula was 4/3 pi r squared. Oh, cubed, I mean. Okay, eyes on the board real quick. If I take 4/3 pi times 3, what cancels on the top and the bottom? So I have 4 pi r. What's one less of the power? Squared. So here's the idea. That is a volume formula. By deriving it, I got the area. Pretty interesting. Mm-hmm.